Hello everyone, welcome back to my channel. In this video, we are going to see how to build a .NET Core 7 web API using Cosmos DB. There are different ways of querying the data using the Cosmos DB, and one of the ways is the link queue and the other way is the entity framework core. But we will see link queue technique in this course. Stay tuned until the end of the video and it will be really worth for it. This video has totally three parts. The first one is we will be provisioning the Cosmos DB in the Azure portal. I have a separate video for that, so if you have already seen that, you can skip that part. The second one is you can also use the Cosmos DB emulator in the local, so that you don't need to invest or even worry of any of the pricing that you will be incurring in the Azure portal. Though there's a free tier, but just these are the options. So if you have seen these two in my previous video, you can directly skip to the .NET Core 7 Web API part. This is the third part. We are going to use the Visual Studio IDE to build the .NET Core 7 using the link queue technique for the Cosmos DB as the database. And Task Manager is the application. Come, let's get started. And here is the first thing. Here's the portal that I've logged in. So here in the search box, go and type Azure Cosmos DB. The overview blade will show you if you have anything. If not, we're going to click on the create. If you look at this, there are 6 APIs that's supported in Cosmos DB. The one is the NoSQL, and then you have PostgreSQL, MongoDB, Apache Cassandra, and then the Cosmos DB for table, and then the last one is the Cosmos DB for Apache Gremlin chart, right? So now each one of these APIs are really supporting those respective stuff. Like if you say you have a MongoDB, that is all supporting the document related stuff getting saved in database, right? So if you're going to take that and migrate it to Cosmos DB, yes, Cosmos DB is the good one. It will support your existing MongoDB stuff, and then everything looks good. There's no other special effort that you have to do. So similarly, all these other supporting 5 stuff are very good at the Cosmos DB. Now, by default, if you don't know what to choose, if you're new, the best thing that you choose is the SQL API. Okay, the SQL API is supported, the first one, and that's the core API. We call it as a core API in Cosmos DB. Right, so based on your project need, you'll be choosing the API. Remember, once you choose the API when you provision an account, you cannot change it later. So that's why this is important and the very first step to carefully choose which API you want. I'm going to choose the core API as my default API. Okay, so here you have to provision your stuff. So first thing is the subscription. Select the subscription, provide the resource group, provide an account name, it has to be unique, and then the location close by your location. And there are 2 options called serverless and provisioning throughput. The provisioning throughput, right now there's a default free tier discount that is applicable. You can see it's a 25 GB of storage, and the first 1000 RU. I will talk about what is RU, each RU means. So I'm going to choose the provisioning thing so that I can make use of the free tier advantage. So I'll choose that, and then the rest of the things I'm going to leave it as the default. Basically, they're all networking, the distribution of the Cosmos DB within the region and outside the region, all those things, the backup policies, like how frequently the database has to be backed up, all those things. For our time being, for a simple demo to understand the Cosmos DB and how to access it through the application, this is sufficient. So I'm going to leave it as it is, the default stuff. Right, and then provide a tag. This is only for my understanding and for the billing purpose. Tag is all for that purpose. You can actually group the resource by the tag you can see how the billings are happening and all those things. Now click on the create and review and create. If everything looks good, it basically says based on what I have chosen, within 2 minutes the deployment should be done. Let's wait for a few seconds. The deployment is done. Actually, I paused it, so the deployment is done. You can click on go to resource. It will take you to the Cosmos DB overview and then the quick start page, right? The quick start page, basically it will prompt you to choose start creating the containers and then download any of these default apps. The default code, it will give you the piece of code. We're not going to do that. We're going to build the web API itself. So if you click on the launch quick one, it will tell you kind of it will navigate through one-on-one items and say what it is. Basically, the first one is the database ID, and then the second one is the throughput, right? So the 1000 RU, the request unit, is very important. So that is what is given for us. It's free. So I'm gonna show you how to do that. So the first one is database, the second one is throughput, then the container right? So once you're done with the container, then if you click on create containers, it's gonna create a default one, but I'm gonna do by myself. So I'll start from first. If you look at this, the free tier 1000 RUs are available. What is RU basically? When you read a data which is of 1 kilobit document size, right? That's called 1 RU. More than 1 kilobyte will take n number of RUs, maybe 2 RUs or 3 RUs. So that's what it is. So I chose the new database. I gave a name, Personal Task Manager DB, and then the database max unit I'm choosing as manual, not auto scale, 400, because I wanted to make use of my 1000 stuff, my 1000 RUs, right? So I choose like that. I gave a container ID called users, and then there should be a partition key for each of the property. I mean, one of the property in the container, you should give a partition key. Okay, and that partition key will be unique. So I'm giving as user ID because we're going to create two containers called users and the task. Okay, so we're going to develop a task management database shortly, and then the task management web API also. All right, so I created a user container, and if you look at this, it has we can actually put a JSON data which has these properties: ID, user ID, name, email, and settings. It basically shows the user and user's informations, and it uses specific settings. Now I will do couple more items so that we can add few items inside the user's container. Container, think of container as a table. If you translate into RDBMS, containers are nothing but tables, items are nothing but the records inside the tables. Okay. Now the extra thing, if you see underscore, read, self, e tag, all those are by default the Cosmos DB will add for each and every single item. And if you want to query something, there is a default filtered where you can directly say select star from C where C.name, like names are nothing but the properties. You can query through the properties, you can filter it, you can also click on the new queries and write similar queries and get the data. That's why you see the data on the Azure portal, on the Azure Cosmos DB account, and where the database is set up, right? So the setup of the database, inside that there's a container called users, inside that there's an items, and under items you can actually do all these things. That's how a container and the items are set up. Okay, so we're going to develop a real API. That's why I'm setting up these things, not just the dummy data. Okay, now the next one is I want to set up another container. Okay, another container called tasks. So for that, click on the new container in the top, and it prompted you to the right side of the new container. I will choose the existing database, and then the name of the database, it's already populated. Container name is nothing but task. Here I will leave all the properties to be auto indexed, and then the partition key here in this container also the user ID. Okay, because each user will have n number of tasks, so I'm associating based on the user ID. Now everything is good. You can add more unique keys and other stuff. I'm not doing that for now. It's a simple two container with items. We're gonna explore how the Cosmos DB is efficient. So we're done with this, and then we're gonna copy paste few items, with the sample items, and so that it goes and stays in the task container. And if you look at this e tag, just note down this number, right? So this number every single time when you do an update, when you do an update means when you modify some of the information of this particular thing, it will change. Now if you click on the keys, there are two keys, the primary key and the secondary key. Alright, primary key is what we will use, and secondary key is when you have to rotate the keys, you need to use the secondary key so that the application is not stopped in between. You can also go to the Query Explorer, you can do more queries, you can click on connect, you will end up seeing the URL, the primary key, the secondary key, the connection string, everything. You can also click on the download sample app, and it just follow these things, but basically it asks you to create a separate database in the containers based on how the codes are by default pulled up from the Microsoft repository. Okay, so basically it asks us to create a container. This, if you initiate like this, it will create a sample database, and then inside that there will be a sample containers, and it will itself load data, and it will show you how to do it through the code. But don't worry, all those things .NET code, I'm going to show you how to build the web API itself. We will do it. See, it has created a to-do list database. Inside the to-do list database there will be some containers, and based on that only it will give you some code. After a few seconds, see, there's an items is the container name, and inside that there are more items. There is nothing but the data, it's loading. And you can come here, you can click on download. It's going to download because they're all pre-written code. That's why this all is available. Okay, so don't worry about the code. We'll talk about more in I'm going to hit enter on this link. I will give you in the description. So this will download a setup file. Once you download this MSI file, just run it in the Windows. Okay, so I'm using Windows 11. I'm using it, I'm running it. So it's going to ask me some permission to install the software. And once I give, it's going to copy, the installation is done, and I will launch it. So it takes few seconds to launch, but once you launch, you can see the launch will happen in the browser. It's not a desktop app, okay? So it's running in port 8081. And here is the thing, the URL. URL here it shows https localhost port 8081, and then the primary key string, and MongoDB string. If you remember, in the previous video we saw how to provision in the Azure portal the Cosmos DB account you have to create, and then you do all these things to get all this URL and accounts and other stuff, right? So you can now use this in the local development itself. The Cosmos DB emulator is running. Now we are going to do the exact same thing, the database, the containers, the items, the throughput, almost everything. The only difference between the limitations, I would say, between the local setup and the Azure Cosmos DB service itself is the Cosmos DB emulator supports only the NoSQL, the SQL API. It doesn't support any of the other 5 APIs. Okay, if you are okay with and used only with the SQL, this is more than enough. Go ahead and do it. It's all free. You don't need to worry about the account and other costs in the Azure portal. So I'm setting up the database, I'm setting up the container, and then you also specify the partition key. Whatever I did provisioning these database containers items in the Azure service, the portal, I'm doing exactly the same thing here. So we have a tasks, we have users container, and then each of these will have its own items. Okay, you can also see if I go to the portal, I have under the data explorer, I have these two, right? The database name is same, the container name is same, only the data differs. Okay, but down the line we're going to see .NET Core 7 app web API development using this Cosmos DB. We will use both local as well as the direct Azure deployed account. Okay, so we're going to use both and show you there will not be any difference at all. And I'm going to copy these content and put it into the emulator so that we will have some data in the emulator as well. Okay, so here how you filter, like you have a query, you have new queries, you have inbuilt query filtering, all those things, right? So we can do the same thing in the emulator also. So I'm actually filtering a user with the user 123, user ID is user 123. I can get 3 tasks. I'm going to copy a couple of items and put it into the emulator. So I'm copying it, I'm going to go to the emulator and put it and slightly change some information. So I copied, I went to the emulator under the task container under the items. Okay, literally I copy everything from here. Okay, so the users are same, so that we will have some difference which I will show you shortly. So I copy it, and you can also see whatever you see here, right? The store proc, the functions, and all those things that are applicable in the container, they are applicable in the emulator as well. So I copied this data, going to paste it, remove certain tags which are not required, which will be generated by the Cosmos DB itself. We don't need to do all those things. So it's generated. I'm going to do few more data. So I saved a couple of items. So you can see few items, I mean the task under the items. Okay, so you have few datas in the emulator as well as in the container, I mean in the portal. Now just to prove you that there is no difference between the emulator and the real Cosmos DB account, I have a web API which is built using the .NET Core 7, and that uses the Cosmos DB. And if you go to the app settings, right, so there's only one setting called development, and right now the development is pointing to the real Cosmos DB endpoint, lsc-cosmosdb.documents.azure.com, right? So that's the real endpoint. I'm going to change the development into the local, and then I'm going to add something called production. Production now will point the real Cosmos DB details, which is in the provision in the Azure portal. But the development will now point to the localhost 8081 port. Okay, the primary key and the primary keys are different for these two, but the database name, containers, everything is going to be same. Okay, so I'm going to slightly modify. Development will have the endpoint as localhost 8081, and then the primary key, I'm going to copy this and put it here. I'm going to replace this because this primary key that you see, it's a real Cosmos DB primary key, okay, which is in the Azure portal. Now, if I run this application, what will happen? The datas with this task container and the task container in the portal are different. There are few data same, but few datas are different. So I'll show you when I run this endpoint. Okay, you'll see the data coming up differently. So right now it is pointing to development. So when I use user 123, that's the user ID. Both are common, both are there in both the places, but the number of tasks between these two users are different. So under the user API, 123 is there, 122 is not there. You see this 404. Alright, so now what we will do, we will see what data is coming from 123. So we are getting some data. I'm going to copy this and then minimize it, go to create endpoint and going to slightly modify and create a new user ID, the new user item. Because once we create this, if we go to the localhost emulator, you can see the newly created data, which is user 121. Okay, that will be saved in the local Cosmos DB emulator. Okay, that proves us that there is no difference between this and that, and in order to do all this good development work using the SQL API, this is super easy and it's completely free. So this is the best that you can do. Now what I'm going to do, go to Data Explorer, expand the users, and if you go to items, you see this user 121 has come. The 121 user has come here only because we use the endpoint which points to this localhost. Okay, now I'll stop this process. I'll stop this endpoint. You can also provision this through the links available here. You can click on it, it will take you to the portal, and this also has the containers, database, almost the UI look and feel is almost same on my screen. So I'm going to open up the Visual Studio, which I have a 2022 version. You can use the lower version also. I am using the community version, which is free. Now I'll create a new project and choose the API as my project. Like if you go to the search, it will come, just type API. So .NET Core Web API, I select it, and then here's the thing. So here you provide a project name for your project and then choose the location where it has to be saved, and then .NET 7, if you have not installed, install it. I will give you in the description, but so I'm choosing .NET 7 as the version because that's the long-term version that is currently there. So I selected it, and then the project has been created. Now this is the default template that was created using the Visual Studio, right? So what we are going to do is, and if you go to the Azure portal like we saw in the first two clips, right? So this is the database that we have. So I have a name called Personal Task Manager DB as the database name, and then there are two containers, task and the users. Task will have these properties. Basically, you will be using labels, attachments, subtask, and description, priority, all those things, right? And then user will have a couple of properties. See, user also we will be eventually using it when we integrate into AD-B2C. But let's start with the first one. I'm going to create a folder and I'm going to name it as core. If you've seen my previous .NET Core video, I have layered architecture, but to keep it simple for this video, I'm keeping every single thing in the same project, like the entities and database stuff, everything. Okay, but just follow the architecture, but for a quick learning this is sufficient. So we will create a folder and I have a class called task document.cs. Task document reflects the container name in the Cosmos DB. So the first one that we have is the ID property, right? So public string ID, and here you have to specify the mapping of the JSON. So there it is mentioned as ID small letter, right? So we have to bring up something called JSON property, and for this we have to install package. We will install the package so that we can pull up the namespace here. So right click, go to the NuGet package manager, go to the browser and say newton.json. Okay, so install the latest version. As of this recording, 13 is the latest version. So now I brought up this attribute. So once you mark an attribute for JSON property, when it converts and reverse conversion, it will automatically map to the JSON properties, right? So now similarly, just to save some time, I copy pasted the rest of the properties. They're all same, right? So we'll go through the properties if you look at this, right? So we have subtask, we have attachments, right? So for attachment itself is a class which will have a couple of properties, and subtask itself is a class which will have eventually a lot of properties and attachment, titles and all those things. Eventually these attachments, subtask and all will come to the main task document property, right? So the next one that we will do was the users document. So users document is a container in the Cosmos DB we saw, and items, right? So the definition that we used there, I'm going to use it here. So here if you see, there is something called user settings and then user document, right? So these two are the classes and they have the relationship. Like I said, see, this is what we are not going to talk about the relational database. This is a non-relational database. They're like a JSON format. That's why Cosmos DB is all about. So now coming back to the program.cs, because we're using .NET Core 7, right? We can simplify this. So first let's install the Cosmos DB related one. So Microsoft.Azure.Cosmos package, install that package, and while it is installing, so once you install this latest package, as of recording it is 3.35.0. now the next thing that we have to do is we need to add a folder and we will name it as data. So anything that comes in the data folder is equivalent of a separate project related to the database, right? So we have seen already that the fourth layer, the data layer, right? So I'm bringing up those things here directly to simplify this and speed up this learning. So the first interface that I will have under this data folder is the task repository database. Task repository interface. So task repository will bring up one method first. So this method is get all task async. This method is an async by nature. That's why the async keyword is there, and it returns a list of task document. Okay, so enumerable of task document. And what is the input? Input is the user ID. So based on a particular user, if you provide the user ID, it will go and pull up all the tasks related to that particular user. That's what all this method is going to do. We need to implement the shortcut that you can use is first you have to create a separate class which will implement the task repository. So the class that we will eventually create is the, just to keep the name same, task repository. So now this implements task repository. So control period will ask you want to implement all these entities. So we have defined that, we have bring up all those definitions. Now next thing is go to the program.cs, right? What we will do here is we have to configure the database, right? So the first thing is we will pull up a variable called configuration, which can be pulled up from the builder.configuration. This is nothing but configuration that if you have used in the lower version of .NET Core. Configuration is coming from this builder only. So builder.configuration is equivalent of configuration. Now once you bring up that, what we will do, we will say builder.services.add singleton, and then we will have the one parameter, just provider. You can name whatever it is, but meaningfully provider gives more meaningful, so that's why I named it as provider. Now what I'm going to do is I'm going to pull up three information from my settings, the app settings. Okay, and those three are endpoints, the primary key, and the database name. Now once I copy paste this piece of code, right, basically if you see line number 15, Cosmos DB settings endpoint URL, which means the setting is there in the app settings, which we will see now shortly. Okay, we will take a look at those three settings, how it is configured in the app settings.json. Okay, now the next one that we will use is we will use a variable within that singleton service, and we're going to say Cosmos client option. There is a class called Cosmos client option. This is coming up from the Microsoft.Azure.Cosmos package that we installed during the starting of the project. So here you can assign the application name. Application name is nothing but the database name. Okay, we can also add some logging information. So we will say we will create a variable called logger factory, and then we will create a logger. So logger factory dot create, and then given the builder as the parameter, we can configure some logging inside this small function. Okay, so just for simplicity, we are just saying builder.add console. Anything that goes wrong or anything related to the database operation, you will see it in the console when you run the application. Now, the next part is the last part and the important part. So we will create Cosmos client. So Cosmos client will accept a couple of parameters where we will have to provide the endpoint URL, the primary key, and the Cosmos client option. Cosmos client option will eventually have the database. Okay, and then you have to return the Cosmos client. So this is what this add singleton service is doing, right? So we have configured the database of the Cosmos DB. How this endpoint primary key we can switch according to whether we are going to put it into the Azure, or we can use either the Azure or the local Cosmos DB emulator. Okay, so the gateway, right? So there's something called gateway that is also important. There are two options. One is the gateway connection, and then the second one is the direct mode. Gateway mode is your application is communicating to the Cosmos DB through a gateway or a proxy, which means it's not a direct connection. So when applications are hosted outside, right, from the company premises, then they will use to have the gateway option. If it is a direct mode, which means everything is sitting within um, the organization's itself. Okay, so in-house, that's why they use it as direct. But for our example, right, we are going to use everything in our local, so we will use direct. But you should understand what is the difference. There will be a slight milliseconds or some seconds difference when you use the gateway and the direct. Now let's go to the app settings.json. And if you remember, we were using three important things, right? The Cosmos DB settings of endpoint. So we were using the three settings: Cosmos DB settings of the endpoint URL, database name, and the primary key. See, if you look at this localhost 8081, we saw in the second clip, it was all coming from the local DB emulator. So that's my URL. You see this? So I can use my local DB for setup and development, or I can use the Azure. But this is very easy, guys. If you are using it for the first time, if you don't know, if you don't have an account, with this itself, you can use everything locally. Okay, so that's a good start. So now if I have to add a production configuration where I will use the same settings, but here my the primary key and the endpoint URL is going to point to the real Azure Cosmos DB, right? So I'm going to copy this URL, and I'm going to copy the primary key of this one and going to paste it there. See, the reason why I'm showing these things is eventually, if you follow my courses, after this is the base application. I'll be using this for so many purpose. Lot of Azure related stuff, we will use it on a real-time basis, like how the real company uses a lot of things, right? So real-time examples I'm going to show you. Now if you go to the launch settings, there's something called project and the IIS Express, right? So this is where you will see where to load. Now we will add a new controller. So when you add a new controller, choose the API controller, and then choose just the empty controller. Do not choose anything else. So we'll start with the empty fresh controller called task controller. If you remember, we have one I task repository, right? We will eventually implement the method, but what we are going to do here is we are going to pull up some information for a particular user. So the first endpoint that we will use here, which is the get endpoint. Okay, so what it is doing is it is going to return a list of task document, which is nothing but the I enumerable of task document, and then the method name is get all task, input is the user ID. So here is the thing. So here what we will do, we will use the I task repository injected here. So for that we have to bring up the constructor. CTOR tab will give you the constructor short form. That's how I use the shortcuts. So once you have the iTask repository, just control period will give you the options to implement. Bring up the field. That's when all these three codes automatically comes. Okay, these are the tips. Now use this task repository dot the method that we already have it, assuming that this is implemented, which we will do it right now. So we are going to use this task repository, and then we are going to call the method which is already defined there, which is, you see this, get all tasks, pass the incoming user ID, and then just await for the call, because it's asynchronous call. So we will use async in the starting of the line number 19, and then we'll use await keyword, and then just return OK. OK will eventually return a 200 status code. That's important if you guys are new for this web API. 200 OK. OK means 200 status code. Okay, for the get, list of items will be a 200 OK. Now let's go and implement here. So before we start, just to recollect, we have the Cosmos DB configuration done in the program.cs. Okay, we just need to use it. So here, bring up the constructor called task repository constructor, and then inject something called Cosmos client. Once you inject Cosmos client, that's when I say inject, it's a direct class, so we are assigning it. And then you can also inject iConfiguration. iConfiguration injection will help us to pull up certain information called like the database name and other stuff. Here we're going to use it, which you will see now. Now these two we have configured, we have the constructor ready with these two, right? So now we will have a private variable called task container. That's the type of container. Again, this is also coming from microsoft.azure.cosmos namespace. So the container here, what we have to do was from the configuration, if you remember, Cosmos DB settings : database name. That's the container, right? You see this? That's the one. So that we will assign it as a database name, right? Alright, so the variable database name will have the database name, and then the container will have the container. In our perspective, container is the task container, that is equivalent of a table. If you relate this to the SQL, task is container in Cosmos DB perspective, and this is kind of a table with respect to the SQL perspective. Alright, so this repository is going to deal only with the container called task. So we will not worry about users or anything else. Okay. Generally speaking, each one will have their own repository. So this really makes sense, and this is a realistic coding but followed by the coding standards. So we're going to use the next one that we're going to use is we're going to take this task container, and we're going to pass these two parameters and create a container. So Cosmos client.get container, we are going to get a reference of this container. So the database name, the container name. So these two are the input parameters. So once you pass these two, we should be able to get the reference. Alright, the first one is database name, the second one is the task container name. Okay, so we got these two, so we have the container reference. Now it's pretty easy. Now let's jump onto this method. I remove this non-implemented stuff. So let's have a variable called query. So here what we're going to do is we're going to use this task container, and there is an inbuilt method called get item query link queryable. We are saying this is a queryable of type task document, and then we can use the var class and say user ID. If you remember, all these things are intelligence coming up. So task document have a definition called user ID. That user ID is what we are defining it here, and then we finally convert to feed iterator. This is an iteratable query. So the piece, like, the line of code from 23 to 26 is just a query. Okay, so we're going to define the task variable, and then we're going to go through the result of this query. That's why we have a while loop in line number 28. So query that has more results, which means more than one record. Then we're going to get one by one and insert into the task variable of line number 26. You see this query dot read next async. Asynchronously it needs the next record of the query, and then we're going to put that into the task variable. Okay, that's because that is a list of task document. Great, you can use the task.add or task.add range, and then we will finally return the task. That's it. See, this is very simple, right, compared to what you have seen in Entity Framework Core. Entity Framework Core is a little tricky, and trust me, LinkU is much easier and very good compared to Entity Framework when we deal with the Cosmos DB, because Cosmos DB is not really, the relational database. Alright, now the iTask repository that we added, we have to add that in the dependency list, right? So we come to this place, the program.cs, we use the builder.service.add scope, we will configure the iTask repository. Great. So this is all configured. It's good to run. It's very simple. You see this in what 15 minutes you learned to build this itself, the complete thing. So we will build eventually everything, all the rest of the methods. They're very super important, and I'll show you how the UI will looks, which is based out of this API at the end of the course. Now, once we configure this route, if you see, because we're using the .NET Core 7, the Swagger is inbuilt, it's automatically coming. We don't need to do anything. Now, once we say user 123, it's gonna hit the breakpoint. It's going to go through that. See, we received that because of the route. It going to get some data. If data is there, it's going to get. If there's no data, it's not going to get. But based out of what we saw in the previous two clips, we know there is something called user 123. That's where we received data. So now we will just run it, and you should see some data coming out. Great. See guys, this is very easy. Okay, if you know the concept of my previous video, we are going to build industry standard web APIs. Okay, no shortcuts. All what I'm showing is really industry standards because I work in IT industry. So I'm going to show you very good examples. Now here, the data that we saw was coming from the development. If you remember, we have two configuration. One is talking to the local, one is talking to the Azure. If I just come to this launch setting and change this environment variable to production and run it, right now I'm going to use the same thing. And in production, which is the real Azure database, the data is different, right? See, now the data is different. That's how you can easily switch, and that's how it actually works. We don't need to do any extra stuff, right? As long as the database name is same, the container names are same, our application is going to work seamlessly good. Great. Now, next set of things that we are going to do is really, similar work. We're going to do the next two set of get endpoints. So we will start with the verb called http get. We will just say task ID. So in this case, we will provide the task ID and the user ID, which means for a particular user, we are trying to pull up a particular task ID, like the task information, not the list of tasks, only one task. Okay, so we will have eventually different types of endpoints. That's how you will learn. You have to know how to build different endpoints of same type in the same controller. So in our example, we have three get endpoints. One is based out of user ID, one is user ID and the task, and the third one, get all tasks. The route alone is different, but it is equivalent of the first one. You can use the same method also, but it's okay, it's all demo, so I'm going to use a different method. Okay, so get all task for user, that's a different method. Probably the code is going to be same, but the only difference between this and the first one is here, if there is no record found for a particular user, we will going to send 404, which is nothing but not found. So the HTTP status codes are important in terms of web APIs. Okay, for get, it is possible to get a 200, 404, 500. 500 is for exception, 404 is not found, right? When you trying to find a particular entity, you don't find that record, you send a 404. Okay, all right. Now we will add these two methods in the iTask repository, and then you need to implement this. If you come here, control period, it will ask you, can I implement this? We will just bring up the definition, and inside the content, we are going to do it now. So the first one is get all task for user. Like I said, it's gonna copy paste of same stuff, right? Almost same thing. So either I copy paste or I can use the same method. I can literally, when this method is called, I will be passing this user ID and returning the value that's coming up from that method. I can use either way, both are same, but if you want to practice nicely, maybe you have your own methods. One method should do only one work at a time. Okay, more than one work, not more than one work at a time. Okay, so we will try to follow the solid principles as well. Now the interesting thing is the next one, get task by ID. Here there are two conditions, task ID and the user ID. We will start with the task container. right? So through which you will retrieve only one task document for a particular user ID. So that is what we are going to do. So here, if you look at this, what I'm going to do is I will filter it with two stuff, which is the task ID and the user ID, and then I'll take only one task. Okay, why then? If you ask me why take one, what happens if the task ID repeats, right? That's why. Anyway, in our case, it should not repeat. Ideally, it should not be. It should be unique. But that's what the take is all about. You can remove the take as long as the task ID is unique. Okay, that's important. If not, it will throw exception because you're trying to return one document, but it's going to be more than one document. We need to be very clear on this. When it is defined properly, the data are put into that database properly, and it is likely possible during development that we put some dummy data, we tend to forget it, clean it, or you have access to the database directly, so you won't mess up the database. But just be careful. Okay, for practice you can do anything. In practice it happens, and that's when you learn. And don't be afraid if you encounter those things. It's okay. Now there's one important thing that I came across. So what if you want to see what is the query, because when I was building I was getting some exceptions. I was like, I know there was a data, but data was not at all coming. I was really wasting 5-10 minutes of finding out why. Then I realized the JSON property that I was using an incorrect package, and the package was not translating my JSON property at all. So here you go. This query, right, the one that I highlighted, I have put a breakpoint. This is going to convert the query into a query definition. You see this, the last statement is dot to query definition, and then once you use that query and say query text, it will give you literally the query that it will execute in the Cosmos DB. I'll show you now how it works. This is important during the debugging purpose. When you build, if you don't know what's going on, if you want to verify the query, through this method you can get the query, you copy paste this query, you will see whether the query is incorrect or data is not there. If the query is incorrect, you will right away find that what you wrote in the C# is incorrect. You can correct it. That's when you save time, right? So finally, once we get the query, I'm just changing that query into executable thing and doing a read next async and finding the result and returning the result. But this is very important, so I'm going to show you a demo how it works. Like I said, I really encountered this issue. All right, so I'll share sometimes or many times whatever I encounter and how I solve the problems. Now this might give you some warning because response could be null. That's why this green color is coming, but we know for sure this will not happen for us. That's why it's okay for us. So I'm going to run this and I'm going to execute the third one and see how it looks. We got 3 endpoints, right? The third one, so we'll deal with the third one. So I'm going to use the same thing, user 1 2 3, execute. It should have hit by now. Let's go. We got the data. You see this, task 1 is there. Okay, now let's use this task 1 as the document. So the ID is task 1, user ID is user 1 2 3. So this is the valid data, right? So when I come here and then execute that, you see this, I got a query. I can literally copy this query, okay, and then go to this emulator explorer and then say I will start with a new what do you call this, I go to the explorer and then I create something called, I go to this particular container and say new SQL query. I can copy paste this and run and see data is coming. If data comes here, definitely data will come there. Okay, here's the thing, you see this, initially like I said, I was generating the query which has a capital I, and Cosmos DB is case sensitive. Because of that, I was not getting data for like 10-15 minutes. I was really scratching my head, and then I realized the JSON property that I used was coming up from a different package, and that was not at all mapping. And then I corrected it. Whatever I showed you was the correct package, but this is what happened for me when I developed, but that's okay. If you encounter this is what the problem, and that's how you will solve your problems. Okay, and you should definitely tell me if this kind of things are useful for you. It helps me to understand and give you such tips as and when we go. Now we execute, we got the data. See, right now for that particular ID we're getting 404. Actually we saw data, right? Why we are getting 404, that's okay. Alright, the next couple of things that we will do is the code operation. So we saw the read operation. The next one is the create, update, delete. So I'm going to paste those signatures here. If you see, the input that will be used for the create is the task document, the update also the task document, for delete it's just the task ID. Now I will bring up the implementation here. Okay, the signature we defined, and it's going to define as the signature based implementation. So all these three methods will come here, and fairly simple. I'll explain you. We will use the task container dot create item async and pass the task. That's it. For update, you pass the task and also uniquely tell what is the ID. Task.id will be the identifiable stuff which based out of the task itself is updated. And for delete, we will use the partition key of user ID, and then we will pass the task ID so that it will do a repartition. So we will explain you what is this, right? So what is this partition keys? So we use the partition key and then pass the task ID, right, for this method. And what it is doing is, by providing you the partition key of during the delete operation, it basically it's going to be very helpful. Okay, so in summary, what it will do, the partition key is used in the delete statement to specify the partition key value associated with the task document. So you wanted to delete that, ensuring there's an efficient deletion occurs in the correct partition. That's why we use this partition key of user ID. And don't forget, user ID is a partition key in both the containers when we define the database in the containers, right? That's why we are sending user ID as a partition key. Now coming back to the task controller, right, we have three methods: create, update, delete. So which means we will eventually copy paste three different set of methods here, and I'll explain you one by one. So let's go to the create. This will be marked as HTTP post because it is going to be a saving of an entity. Okay, here input is the task document. What we are going to do is we're going to preserve, we are going to generate the task ID as a unique GUID. So we generated it, we assigned it, it doesn't matter what they send, we will always generate it. And then we call that repository method, pass it, that's it. The task ID is used and the task is created, and we will send us the created one. Created, action created will give us 201 status code. Remember, HTTP post will eventually return a 201 status code for creating an entity. For update, it's going to be a 200. If you look at this, task ID and the task document is the incoming. Here we will preserve the task ID and then the original task ID so that it's not overwritten. So that's how we use the task update. And for delete, it's same. We accept it, we delete it, and then we return a no content. Okay, 200 no content, 204 no content, sorry. So that is what these three endpoints, and what we are going to do, we are going to first see the first one, user 123. Okay, and we will get the data, we will use the update, and then we can use the new create. So I'm going to copy this content, okay, and then slightly change these content and going to use it for the HTTP post. Now come here, do a try it out, copy paste it. See, it's completely copy pasted. I'm going to just change the task ID. Anyway, ID is being generated as a give ID. Okay, we don't need to send. Now we can just adjust some of the properties, or even I can execute it, and it says 400. What it says? So at least it says the task field is required. We're not sending the task at all. Okay, there is something wrong. What is that we are doing? Okay, you see this task ID was not having the double quote, so it didn't even get that JSON properly. That's the problem. Alright, so once you do it, we got the 201. Remember, HTTP post is always going to be returning a 201. That's the right status. There are always debates that it can return 200. That's okay, but 201 is the right status. Okay, in terms of interview, 201 is the right status for HTTP post. Alright, so what we're going to do is probably we are going to copy that, and we can generate a couple of tasks, or we copy whatever we just created, come to this post, provide this task, that ID that we created, and copy paste it and update some content, because update is all about updating some properties or many properties of the task. So that is what we are going to do. Okay, so we clean up this, we copy paste whatever we copied from the created stuff, and then I'm gonna remove something. So we will remove some items from the subtask, or maybe we will modify, we'll rename it. Okay, so I'm gonna rename the description. I'm gonna keep all these things. I'm just telling you, like, you can actually change anything. I'm going to change the due date. Okay, and executed it. Let's see what happens. It have hits us the get endpoint. Okay, run, and then we will remove this, we don't need it. And then 404. Okay, so we tried to update certain thing which we thought it was valid, but it returned a 404. So we need to find out what is wrong. See, task ID only we should send. Task ID, if you remember, it's a give ID. Okay, task ID is mapping with the ID. Probably we'll change this mapping to task ID and ID to ID, but right now task ID is mapped to ID. So once I paste this properly, I got a 200. Everything worked good. Okay, so we can also understand bad request. 400 is a bad request. If the request is incorrect, it cannot fulfill. That's when you get a 400 status code. Okay, I've already explained about all the status code properly in many of my complete web API tutorial. You can go take a look at how the .NET tutorial I've done with different things, but this is what this 400 is all about. So now we have three working: get endpoint, create, post, and then update and the delete, right? Alright, so two more things. What I'm going to do is I'm going to create two more methods. Basically what we are going to do is, what if you have to update a particular task status, right? So that's when our UI is like, if I want to update a particular substart status from in progress to completion, that's when you can do. And you can also update a particular attachment and all those stuff, right? So that's when those two endpoints are there. So in order to build those two endpoints, first I'm going to create two methods, two classes called attachment update request and subtask update request. The first one is going to use a complete list of new attachment and then the attachment to delete. Okay, so if you look at this line number 89, right, that's when we bring up the namespace here. So this one is basically for a particular task, subtask, we are going to update its status. See, for a particular task ID, and then the route is under a subtask, under a particular subtask ID, the status we are going to update. That's what this route is all about, and we will use HTTP method called HTTP put. HTTP put is for the update, like you saw in the update statement. This is also update. For a particular thing, we can also use HTTP patch, but for this example, I'm using HTTP put. Okay, alright, so if you see the signature, it is very simple. Again, it is calling another method which was sending task ID, subtask ID, and what is the status. Whatever status is coming, it will update. Similarly, for update attachment, it is going to read the request from the body, okay, and then it is going to send those two parameters to another method called update attachment. Okay, these two properties, and then the route will be task ID / attachment. Alright, which means now we know there are two methods which is not there. We are going to create those two methods in the iTask repository. Okay, basically we're trying to build a realistic real-time API which will involve these kind of actions, right? You created a task, you will eventually create a subtask. You might need to update only the subtask. You don't need to use the complete put operation for that. That's why these two examples also I brought up. And again, this is also simple. We will do a control period to bring up the definition here. Okay, those two methods we need to implement it, so we're going to do that. And then here's the thing, so I copy pasted those two methods. I'll go over this. It's very easy. The first one is update subtask status. It receives a particular task ID. We go through that similar code, get the data. Once the data is there, it's okay. If data is not there, we will return null. If data is there, we will go and fetch the particular subtask ID. Once the subtask is there, we will do a replace item async, and then we will return it. It will save it. That's it. Similarly for the attachment, if you look at this closely, we will bring up the complete task document, and then based on the incoming add and the delete, it is going to add the incoming new attachment, and for delete it is going to remove whatever we told them to remove it. So the attachment also has the ID, right? If you say remove a particular attachment, we will go through it and remove a particular attachment, and finally the task, the complete task has been will be saved, and we will show you the full working example. So I'm gonna use the same user, get the data, and then you see these two put methods. It's an update method, it has newly we developed. So what we're going to do is we're going to go and change the status of one of the subtasks. Go all the way through up for this task ID. We're going to take the subtask ID and we're going to change the status. Okay, I'm going to scroll down and you see this subtask ID is subtask 1. Okay, so I'm going to come here, put the task ID as proper one, and then subtask ID as subtask 1. Change the status to a different one. Probably I'll say incomplete. Okay, I execute it and it should see, if you look at this, the one which has done. So from done, I'm going to change to something else. Okay, there is no as such validation of what we are supposed to change, what we are not supposed to change, but we're trying to change it. Like we did the similar mistake. Task ID is incorrect. We're going to retrieve the task ID properly. Alright, so we will see it. It's a case sensitive. Subtask 1 doesn't have a T capital letter. Now I received a 200. Now if you go and execute the same thing, here the first one was done. Right now it's changed as incomplete. So we did not touch any of the other properties. We just specifically updated a particular item, a particular property of the whole document. Okay. Now similarly, attachment. If you see the attachment of the first one, it has two items. You see this attachment 1, and the ID is also again attachment 1, and it has two different items, or maybe it's the same items, whatever it is. So we are going to copy this and use it in this statement. So under the attachment, I'm going to put this, but I'm going to change the property value. Okay, so I'm going to pass two items, two attachment 5 and attachment 4. Now attachment 1 is not present. We're going to delete that. Okay, now it says there's something wrong. Again, it looks like a quotation that we missed. Let's see what is wrong. See, anytime that you specify something incorrect, request field is required. Okay, from this clearly it says it did not reach properly. This JSON is incorrect. We just need to find out. Alright, now it looks all correct. I executed it, I received it, which means if you execute this again, the get one, right? Attachment 1 was there, it's wiped off, we deleted it. Rather, we inserted 4 and 5. So the endpoints that we developed, it really worked well. There are here and there small hiccups, but that's when you learn the mistakes and change. That's how you troubleshoot it. Alright, all these are working good. Perfect, we saw a very good example. Now similarly, we will have the user documents controller also. Okay, so I'm going to save some time of yours. I'm going to do exactly similar work. So I'm going to create a I user repository, and then we're going to do a similar work whatever we did in task repository. If you've learned task repository, user repository is almost same. So I'm going to speed up this process. So I have 4 methods. It's doing basically create, delete, update, and get, 4 basic CERD operation, right? And then we're going to use the user repository and then implement the iUser repository. Exactly same. The only difference here is the container name is users here, not the task. The rest of the stuff is almost same. You can literally copy paste and change it. Okay, that's what I was also doing. But it's easy, it's really easy. You just need to pull up the namespace, and then you see this, everything that I'm highlighting is all same. Deleting, creating, updating, because the hard part is the task document, which you have already seen. So we will hook up our dependency injection for the iUser repository here quickly. Once that is done, and we just need to have a controller for the user task, and we just need to have a controller for the users. So we bring up this, the route will start with API slash followed by the controller name. Our controller name is users. So we will eventually have an endpoint for the users under the users controller. Again, we have HTTP GET, HTTP PUT, HTTP POST, HTTP DELETE. 4 basic commonly used verbs, HTTP verbs. And the routes are defined here properly. The input is also defined. If you run this, the Swagger will kick in automatically because we're using the latest .NET 7 core, .NET Core 7, right? So everything is going to work. Once you run it, we will be able to create users also. Now, remember one thing, when we did this task document, we assumed there is, not just assumed, we created users in the first 2 clips. Based off the user ID, we created the task. So what we will do eventually with this application is, when we integrate ADB to C, user ID is not like kind of a dummy data. We will pick it up from the object ID of the Azure ADB to C logged in. Okay, so we will use those as a real user ID, and then we will develop a nice UI and all those stuff. Anyway, now the user's controller is ready. These 4 things, if you create the users, it's gonna commit here, and you can use this delete for the task and delete it. So let's say user 123. Let's pick up some users. Let's pick up some task. Alright, so this task ID, I'm going to delete. I don't like this. Okay, I'm going to use the delete statement to use this. So task ID, user ID is 123. So this one should go away. Done. No content will return 204. That's why you see the number called 204 as a status code. Great. See, that's gone, disappeared. Great. So delete is working. All good. Now, similarly, you can quickly create users. So here, if you see users 123, if you pull up, this user information is coming, right? So I'm going to copy this, go to the create users, paste it, change some name, going to create a new user through the API, not directly to the Cosmos DB. Okay, so I'm going to use this. I created it, I got it, and create. I'm going to go to the put, use this user 1 as my, I'm going to use this user 1 as my update statement. Right, so update also worked. All good. See, got updated. Oh, that's because I'm doing it incorrectly. The user ID is actually user 1. I was trying user 123. That's very bad. Okay, alright, so I changed it. I can literally see everything got updated, and I don't like this user, so I'm going to delete that. Okay, so I'm going to use the same user 1 to delete it, and done. It's deleted, because if you try again, you should get 404. Okay, because we already deleted, right? So that's when that's how it is easy. Alright, so we're going to add the Docker support to this. So quickly, let's go to the project, right click and do a click add Docker support. We will use the Linux, and then you see this set of statements. And if you've watched my previous videos, we have Docker support. So I just choose the Docker, and then, so you see this, we added the Docker support, and even this application is working with the Docker. The reason I showed you the Docker support here is we are going to use, this application for building up, the Dockers, Kubernetes, and all those things. So I'm going to use this for the next upcoming videos for a lot of Azure related services demo. So that's why I added this Docker support. And what I'm going to do is, we saw some error, right? That's because the application using the Docker is using the same port as what the Cosmos DB local emulator is using. That's why it was not working. So once I change the configuration, at least in local, to show you a quick demo, I'm able to see it's running in port 32774, and it worked great. And thanks for watching. Don't miss out the upcoming videos, and I'll see you in the next video. Thanks for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more tech tutorials. And don't forget to hit the bell icon to get notified when we post new videos. If you have any questions or suggestions, leave them in the comments below. Happy coding!